recording now. And moving on to the slides. Right. I hope you can see it. Let me know if you couldn't. So, hey guys, I'm Abolfazl Saghafi, Director of the Data Science Program. And you might have heard about data science. It's like a growing thing, and that might have created some interest to you to know more about data science. I've prepared something which I think is going to answer most of your questions. It summarizes what data science is, why it's important. We go through market demand for data science, and we see what USciences has to offer to students. Then we'll see some fun applications of data science that our students will learn to do by their final year of the program. If you have any questions, feel free to post it in the chat. I'll get to it once the presentation is over. So I'm starting with this simple chart. The chart shows the amount of data generated each year around the world. And it starts with 2007 all the way to 2020. And you simply see that the generated data, it's growing exponentially. And if you kind of pay more attention, up to 2015, it seems to be manageable. It's not that much. But after that, every 2 years, the amount of data has been doubling. And the prediction for 2021, it's like estimation is 50% growth from 2020. The scale of the values over there, it's based on exabyte. It's like 10 to power 18. Just imagine 18 zeros. It's a lot. It's a lot of data. Obviously, we are dealing with a big data situation, with a big data problem. And it's not just about, big data is not just about the volume of data that we deal with. It could also deal with the velocity, veracity, valence within the data. What do they mean? The speed the data that comes in, the interconnectedness between the data, different formats, different types of data. And at the end of the day, we want to create some value out of this bunch of information and data. Big data is happening everywhere. You can see it in retail stores like Walmart, Target, and banking and finance, insurance companies. You can see it everywhere. You see a couple of examples here. A huge portion is generated in media and entertainment. We used to carry CDs around to watch movies, store data. Now things are stored on clouds, which makes them accessible via Wi-Fi everywhere from anywhere. Sports and gaming and entertainment industry, they all create huge volume of data each month. Now, to deal with this situation, we used to have statisticians and computer scientists and business analytics to analyze data and generate some reports, pass it to the CEOs to make decisions. And that could take weeks, not even, maybe like months. But with the current situation, if you wait for a week or month, the situation could change. New data is coming and it's coming fast, and the decisions could change based on the new information. So we need a new ways to tackle this big data situation. That's where data scientists come into place. Think of them as heroes of the day. They're here to save the day. They have a well-equipped set of skills. It is, after all, an interdisciplinary field, which requires math and statistics knowledge, coding and database information, communication and visualization, and some softer skills like problem solving and curiosity, which most of us, all of us, I can say that for sure, all of us have that to some degree, but we need to hone these skills to kind of to master them, and to be able to use them on cue whenever we want to do that. So you need to nurture these skills. You need to master these skills. And to do that, you need some sort of Yoda. That's where we come into place. Here's the data science team at University of Sciences. On top left, we have me, Abolfazl Saghafi, and my specialty is machine learning, deep learning, and statistical methods. We have Carl Walasek. He's the instructor of statistics. His work is on computational statistics and simulations. We have Randy, professor of chemistry and biochemistry. His specialty is computer-aided drug design, and he has actually a couple of patents and a very famous software in computer-aided drug design. Thierry Petit is our computer scientist. His work focuses on optimization and combinatorics. And we have Zijun Li, professor of bioinformatics. His work concentrates on molecular modeling, drug design, and protein engineering. We are also recruiting a new faculty in mathematics who can help us with delivering more concentrated math courses. That aside, so what's the difference between a data scientist and like a statistician and a computer scientist? Can they do the job of a data scientist? What data scientists learn to do is like an interdisciplinary field between a couple of other majors. And basically what they do to manage those pile of information, they have two situations to kind of manage these situations. Either they create pipelines, so when new data comes in, the data goes through the pipeline, which kind of leads to the final decision making. And they create this automated process that feeds the data in, and the reports and answers comes out. And the second way they can tackle this big data problem is to program computer to solve the situation, to get the reports out of the data that comes in. And the computer code does that very fast. Now let's go to the market demand. This I got it from US Bureau of Labor Statistics. They predict a growth rate of 26% in job outlook of 2018 to 2028, which is much faster than the average growth rate. Average growth rate for other jobs is 5%. This is more than 5 times the average growth rate. And you can see the link on the right side. And the average pay, this one I got it from Glassdoor. You can easily Google it and see the average pay for a data scientist. It's about 100K. And that's a that's an average base pay for a data scientist. So it's a high paying job, and it's a job which is in demand after you graduate. Some careers that you can think of when you're studying, some of them include like retail analytics. Retail stores recruit data scientists to find patterns between the purchases of people who come into a store, or maybe online purchases. When you go, for example, in Amazon, you purchase something and right away you see recommendations on the sidebar, which kind of suggests a new product. So these are based on some codings, and a data scientist is behind every one of these things. You can think about recommendation engines. Netflix, for example, if you watch a couple of movies and you rate them as like 5 out of 5, and in the next time you open Netflix, you see some recommendations, some movies which are going to be, maybe they rank high in your list of favorites. In banks, to detect fraud, and some other, in sports, for example, when you watch new sports, there are multiple cameras around the field, and we need a director to kind of coordinate these cameras, which one is going to be broadcasted to TV, for example. When we increase the number of cameras, this decision making could be a very difficult decision. But if you program a computer to do that, to simplify this decision process, that could help the director a lot. So yeah, we have more examples here, and I can share the slides with you later on. Just send me an email. I have my email at the end of the presentation. Why USciences? USciences is number one in Philadelphia, New Jersey, and Delaware for salary after graduation. And we are top 10 in the nations for salary after graduation. We have 3 different majors for data scientists: bioinformatics and genomics application domain, analytics and SAS programming application domain, and an individualized application domain, where students have the ability to tailor their curriculum to some degree. We have close interaction with health professions and natural sciences, opportunities to do internships with a variety of companies. Our advisory board members are in different areas. We have a green light to train our students from members in Blue Cross, District Attorney's Office in Philadelphia, Gene Vaughn and Monell Chemical Center. And we recently signed an articulation agreement with New Jersey Urology Center. And with tuition reset, USciences is now very competitive. 0% hidden fees, price increases, and surprises. And Philadelphia is a major pharmaceutical, medical, and technological business hub. So with that, I'm finishing the presentation. Here is my email. If you have questions specific about the programs, if you want to know more, shoot me an email. Don't hesitate to do that. If you have questions about admission, there's an email over there. And we have about 15 minutes left. And I'm going to show you some of the applications, that our students learn by their last year. I have 4 examples here. If you have like a favorite, send something in the chat, and you can actually follow these with me. I will provide the link to you. You don't have to do any sort of coding, but you will be able to run the codes on your own computer. It just needs a Google account. So if you have a priority, let me know. If not, I'm going to start with the stock market price predictor. Right, I have a question. Can you go more in depth with the government aspect of data science? Government aspect. What do you mean by government aspect? Yes, the government is actually one of the big things that hire data scientists. They have access to like much more information than industries. And in order to kind of make sense of all this information, they need data scientists, and a lot of them, to kind of give some reports so that higher people in the higher administrative people can make wiser decisions, data-driven decisions. If that didn't answer your question, yeah, send something else. Or send me an email. Right, let me can I? Yeah. So this is the link for the stock market price. I'll give you like 2 minutes. Open the link in your browser and just wait. We'll continue in 2 minutes. Once you open the link, this is the page that you'll see. So the codes here are Python codes. Python is the top program with a couple of packages, with most used packages to tackle data analysis. And the credit for these codes goes to Lawrence Morley for base codes. I got the base code and modified it to run my problem. And what we're going to do is to estimate, to find a pattern between prices in the Microsoft stock price. So if you want to follow with me, the codes are in different blocks. What you need to do is to go to the left side of the block. There is a triangle there. If you click on the triangle, that runs that block, the codes for that block. So I'm going to start with the first block. That's the TensorFlow. What it does, we are loading the main package, which is used for data analysis here, TensorFlow. We are loading it into the session. And yes, you can run it anyway. You can trust it. That Gmail address is my personal Gmail address. And you see that it runs it very fast. The version of TensorFlow is 2.3. I'm moving on to the second block. This one loads some other required packages into my session and defines a plot definition. And the next block, here I stored the Microsoft stock market prices somewhere on the net, on the internet, and I'm just loading it into my session. And you can see that it's 100% done. The size of the data was 5.6 kilobytes, and it's a CSV file. And the next block, I'm just reading that data and plotting it. And you can see that the prices has been increasing. It's from the starting price is it's 20th July 2015, and the prices goes up to 21st July 2020. That's the last time I modified the codes. So it's 251 instances, 261 instances. The next block. So what we do in the next block, we partition the data. We use some of the partition to train a model, and the last partition to test the performance of the model. And the next block is running the neural network. Neural networks are one of the most highly sought modeling techniques, which I'm using here. And you can see the model here. It's a convolutional neural network. We're going to use the same model with different structures in the other examples that I showed you. And in the next session, I'm feeding the model. So the algorithm goes through the data, tries to find the model which minimizes the loss. I can see the loss started with 55, and after 250 iterations, the loss reduces to almost 6. It takes almost a minute to kind of train the model using the data. And yes, it's done. And the next block plots the historical loss. And you see that the loss has been decreasing through the training process. We could continue training, and we simply don't have like that much time. So I'm just saving some time here. But we could continue the training like for 1,000 iterations and more. And finally, in this block, I'm testing the performance of the model using the test data set, the data that I set apart. The measurement, the goodness of it measure is about 49, about 50. And finally, the last block shows you the plot of the actual stock market prices. That's in blue. And the lines in orange are the data fit from the model. And you can see that it's not that bad, but it's not like perfect either. It has room for improvements. And we learned to do that by making more complex models. This was just a simple model. So for 261 instances, and I could add some more codes to predict the price for the next few weeks, for example. I simply didn't spend much time to do that. I was a little lazy. Right, that was the first application. We have a few minutes left. Let's go to the second application. And you can actually save these codes and come back to them later. Maybe update the initial data set and try to see what the model performs in a new data set. So in this one, in the second example, I'm going to show you the Shakespeare sonnet reader. So the same convolutional neural network, I restructure that and I make it to read Shakespeare. And in the end, I'm going to ask it to complete my sentences based on what it has learned from the text. Again, credit to Lawrence Morney for the base code. And I'm going to share this one's code in the chat. And we'll wait 1 minute before proceeding. So you can open the link in your browser and follow the codes with me. And if you're wondering, yeah, let me just go ahead and post the other links too. "30 seconds before we continue." Right, let's continue. So again, we move block by block and run each block by clicking on the triangle to the left side. And just like before, the first one is loading the TensorFlow into your session. And then I'm loading a couple of other packages. This one is a more complex model, so I'm loading more packages here. Then we have the Shakespeare sonnet. I'm loading that into my session. This is actually a link. You can open this into your browser and see this is what the sonnet looks like. So the first advice is, from fairest creatures we desire increase, that there be beauty's rose might never die. And just like that, if you go through it, it's like a lot. Technically, it could take you days to just read the sonnet yourself. If you run the next block, the code read the whole thing in less than a second. It didn't take it much time. And the next block, so when I was training this model, it took me about 3 hours to train the model using the data set. But we don't have that much time. So I saved the model somewhere. And the next block, I'm just loading it from an storage. It's 100% done. And you can see the structure of the model in the next block. And as you can see, it has the same, not the same structure. It's a convolutional neural network. It has a different structure, but I'm usually using the same technique here. I'm just repurposing the model. And now I'm checking the accuracy of the model in the next block. And the result tells me that the accuracy of the model is about 87%. If you're wondering how the training performance is done, how the training is done, you can unblock the next 2 blocks and run them. Just remove the hashtag from at the beginning of the code. If you do that and run them, but you have to be patient. It might take you at least 3 hours to finish the training process. And here comes the moment of truth. So in the end, I want this computer program, which has been trained with the Shakespeare sonnet, to complete my sentence. And I'm going with this one. I'm pulling a sentence from Star Wars. Help me, Obi-Wan Kenobi. You are my only hope. And I want the program to predict the next 10 words. Let's see what happens. Right, we have the results. Help me, Obi-Wan Kenobi. You are my only hope. With their blessed end shall toward a breed held sharp pass. Well, it was working pretty good at the beginning, but these things happen. As we move forward, the next words, the accuracy of the predictions becomes less and less. So maybe the first 3 or 5 words, it makes sense, but after that, yeah, it might not. Let's try something else. Or let's try the last one, the last verse. This one is actually from the text itself. So I'm pulling a sentence from the sonnet itself, and I'm asking the computer program to complete that sonnet. Who will be my verse? Who will be my verse? Who will believe my verse? In time to come, be blind. 'Tis so charactered too. Yeah. And one other thing about it is that you can't expect the computer program to do more after just reading one Shakespeare sonnet, right? It takes years and like many books to master these kind of things. And one last thing, just for the hell of it, let's go through. Since I'm a fan of Lord of the Rings, let's go with the "You shall not pass." So you shall not pass, my love. That was good. My love. That love is nothing worth her rider me. That one was good. Yeah, I give it to it. That one was good. So yeah, everything is there. You can play with it later on, maybe add like a new sentences and ask it to complete that for you. And with that, we are at 6:30. Do we stop or shall we continue?
I think we can stop and see if there's any additional questions.
Right. Any questions?
If you have any questions about the data science program or University of Sciences, the admissions process, we can answer any of those questions. If not, you're more than welcome to head out.
Yes, thank you. Thank you for joining us.